So we are going to discuss in today's lesson about Group 1, Group 7, some transition elements and noble gases and their properties. Okay. So we have a little discussion already about Group 1 and Group 7, how they react, how many outer electrons they have. But today we are going to see some more properties and which type of the reactions they can show. Okay. So let's continue with Group 1. Okay. So group 1, basically also known as alkali metals. We say them alkali metals. All are metals in the group 1. If you see in the periodic table, starting with Li till Fr, lithium, sodium, potassium, rubidium, cesium, and francium. All these are group 1 metals. Okay, why we say them group 1 metals? We already know about this because of outer electrons in the shell. They all have just one electron there in their outer shell. We say them alkali metals as well. Why we say them alkali metals? This name also has a meaning. Basically, when all these group 1 metals react with water, they make alkaline solution. I hope you know about alkaline already. It is something which has pH more than 7. Acidic is something having pH less than 7 and alkaline pH more than 7. So when they react with water, they make the alkaline solution with pH more than 7. So these are basically a little introduction. Then we can see some physical properties of the group 1 metals as well. They all are very soft and easy to cut, that we can take a simple knife and cut them just like butter. Very easy to cut. And they will become more softer and denser as we move down the group. Means if we move from lithium to the francium at the end, the francium is going to have even less, you can say, density. It will be easy to cut. It will be even softer as we move down the group. Okay. So they all have shiny surface. When we just cut them, when we cut the block, the freshly cut surface is going to be shiny surface. After some time, they can react with the air, with the oxygen in the air, and the surface can become dull as well. But when freshly cut, surface will be shiny. They all can conduct heat and electricity as well, good conductors. And can anyone tell me why they are good conductor of electricity? What can be the reason of good conductor?
Because they have free
You can raise
electron.
your hand. Yes, Jana.
Due to the extra electron,
Because of the extra electron. Okay. Little explanation, can you tell me? What the extra electron
okay,
will do?
the extra electron will conduct the electricity. But I'm
Hmm,
not sure. But I know the reason, but I'm not sure the explanation.
no
It's correct.
problem. You can still tell.
Okay, it will take the electricity and give it
Hmm.
to the cell. I mean to the atom. Not
Okay.
sure.
Okay. Yes, Jude.
Yes, miss, because as we said, they are metals. So the metals, they have the metallic bonding, which has an extra electron, or the
Hmm.
sea of moving electrons around it, which will conduct electricity.
Hmm. So yeah, both your points are correct. Also, Jana and Jude. So those extra electrons, because they're metallic bond, it means they will have positive cations and free electrons. Those electrons are freely moving. So when they are freely moving, they are conducting electricity. Okay. So this point is correct that they have extra electrons. So those extra electrons are freely moving. So because of their free movement, they can conduct electricity and heat. Okay. So they all these group 1 metals have low boiling points, melting points, and low densities as well. As we said, they are softer and we can even cut them with knife. Okay. And what happens to their melting point when we move down the group? Melting point decreases as you move down the group. Okay. Because the size is getting more and it will be easy to melt them. So melting point decreases as we move down the group. Okay. After that, we can see some chemical properties as well. If we check out their state, you can say we check out their conductivity, melting point, densities. All these are basically known as the physical properties. Now we can check some chemical properties as well. Chemical properties means checking how they can react and how we can store them as well. Because they are very reactive, they can easily react with oxygen and water vapors in the air as well. So if they can easily react, it means we cannot store them open in any bottle in laboratory. Okay, because they will just take oxygen from the air, water vapors from the air, and react quickly. Okay, so we have to store them under oil. We have to take the block of the metal, dip it in the oil. So inside oil, the oil will prevent the reaction, stop them from reacting with oxygen and water vapors. So like this, we can store them. So group one, why we are storing them? As we said, they can react. So they react what they produce. When they react with water, they produce alkaline solution of metal hydroxide as well as hydrogen gas. We will see some equations as well, how we can get the metal hydroxide solution and hydrogen gas. Okay. So they all are reacting same way. All the metals can react same way with the hydrogen, producing a metal hydroxide solution and hydrogen gas. Okay, group 1 metals are getting more reactive as we move down the group. So when we are talking about moving down the group, what is happening to the reactivity, what is happening to the melting points, what is happening to the density, it means we are talking about trends. What is happening to the group 1 metals when we are moving from top to bottom. So the trend of reactivity is they are getting more reactive as we move down the group. This has a reason as well. The reason is not the part of your syllabus for now, but we can still have a little discussion of the reason because for group 7, we will see the reason as well. Okay, they are getting more reactive. Any idea why the lithium at the top will be little less reactive and francium at the end is more reactive? That's what they said. It is getting more reactive as it is uh, as we are going down the group. Any idea anyone can tell why the top one is less reactive and the last one is more reactive? Yes, Mariam.
I think because they are smaller in the size.
Okay, then.
So they will be يعني أنا مش sure والله بالظبط. يعني
Okay.
they are smaller in the size, so there will be يعني
Hmm.
more space to move around. I think so. I don't know.
Okay. Okay, I can give you a little hint. Then you can tell me the reason. So the hint is when they are reacting, it means they have to lose electron, right? So electron loss is easy means they are more reactive. Electron loss is hard means they are less reactive. Now you can tell me the reason. Yes, Jude.
Yes, I think it's, related to that as you go down, the number of protons and electrons is larger, so the losing of and gaining of electrons are more.
Okay, I thought you got the answer. Basically, when you see what is the period number of lithium, it is in the period 2, right? Period 2 means it has 2 shells. Okay, and the second shell has just 1 electron which needs to be lost. Okay, if you move down, 3, 4, 5, 6, 7. Francium has now 7 shells. So the 1 electron that we have to remove for lithium is going to remove from the second outer shell. For the francium, it is going to remove from the 7th shell. So loss of electron from the second shell, which is little close to the nucleus, having some attraction with the proton at the center, will be little hard. And the loss of electron with the francium having the 7th shell, and the 7th shell will be too away from the nucleus, so loss of electron will be easy in that case. Okay, so francium is going to lose electron easily because of the weak attraction. It means it is going to be more reactive, quickly losing electron, quickly reacting. Okay, and when for the lithium, it is having the outer shell closer to the nucleus because it has just 2 shells. because period number is telling us the shells. It has period number 2 means 2 shells. So the loss of electron hard means hard to react. Loss of electron easy means more reactive. So group 1 metals getting more reactive as we go down the group. Okay, I hope now the reason is clear. Yes, Umama.
Miss, why the Na has one shell? Then
Na is the period 3. It will have 3 shells. Because we said the period numbers are the rows. So very first period is having just hydrogen and helium. Hydrogen we are not taking in group 1 because hydrogen is not metal. We are talking about only metals in the group 1. So it is starting from lithium till the francium. So lithium is having second row, 2 shells. Third row, 3 shell. 4, 5, 6, 7. The last one is 7th row, 7 shells. Okay?
okay, Miss, I
So,
go.
okay, second shell is closer to the nucleus, hard to remove the electron. And the 7th shell is away from the nucleus, easy to remove the electron. Okay, so that's all about the chemical properties of the group 1. Now the reaction of these group 1 metals with the water and what they produce. As we just said, reaction is going to be more down the group. Means the top one will react less and the last one reaction will be very fast. Okay, let's see what will happen then. So if we take the lithium from the top, lithium can react with water and make something alkaline and hydrogen gas. That's what we said already. So lithium hydroxide, LiOH, will be produced. This is alkaline. It means it has pH more than 7. More than 7 is alkaline solution. Okay. So with hydrogen gas. Lithium, all the metals are solid at the start. So lithium state will be solid. Water we are taking in the form of liquid. LiOH is mixed with the water, solution form, so it is going to be aqueous and hydrogen gas will be produced. So reaction will be slow as compared to sodium, which is next, because reaction is going more as we move down the group. Bubbles of the hydrogen gas will be produced that we can easily see. Lithium's melting point will be higher and heat is not produced so quickly because reaction is slow. So the lithium does not melt easily. When it is reacting, producing hydrogen, whenever hydrogen is produced, it means energy is produced, heat is produced. Because the reaction is slow, heat produced is also slow. It is not very quick. So because heat is not producing very fast, it will not melt the lithium quickly. It will remain normal in original solid form somehow. It will melt slowly, slowly because heat is producing slowly, slowly. Okay. Second, we can move to the sodium. Equation is going to be same. Again, 2 NAs in the solid form with 2 waters and the balanced equation is producing 2 NaOH having pH more than 7 because it is alkaline solution producing hydrogen gas in the form of bubbles. Hydrogen bubbles we can see. Okay, now because heat produced will be little faster as compared to lithium. Okay, as the reaction is little faster, now it is reacting little more, so it will melt. As heat is produced, it will melt into a shiny ball that dashes around the surface. What does mean by this? Basically, when we take sodium, small block, put it in the water, because of the less density, it is not going to dip in the water. It is not going to sink in the water. It will remain on the surface. So as soon as it is reacting with the water, it will start melting on the surface and move around the surface just like a ball. Dashes around the surface means move around the surface. At the top, float on the water because of the less density. Yes, Samreen.
Miss, you were saying that isn't produced so quickly. I don't understand that part.
See, what we said, they are getting more reactive down the group, right?
Hmm.
When they react, they produce heat. So the top one is going to react slowly, so it means it will produce heat slowly as well. And that
Okay.
slow heat will not be enough to melt it. So lithium will not melt quickly, you can say. Sodium, because it is more reactive now, it will produce more heat now, so it will start melting. How it is melting? First of all, it is floating on the surface of water because of the less density. All these have the less density. So they float on the surface of the water. And while floating, it is keep melting as well, producing shine as well, shiny ball moving on the surface of the water and melting as well. Okay.
So, Miss,
It
the
melts. Yes,
heat
Samrit.
that heat produced is linked to the reactivity.
No, reactivity is giving us heat. That heat is linked with the melting. Because of the reactivity, they are producing some heat. Less reactive, less heat is produced. More reactive, more heat is produced. That will help the metal to melt.
So, Miss, if it is more reactive, it will
Hmm.
produce more heat,
Yes.
and it's less
And it
reactive, it
will
will release
melt
less heat.
fast as well. Yes.
Uh,
Okay.
yes, Miss.
So it will float on the water because of the less density. It melts because the sodium has low melting point. Plus the melting points are decreasing as well. They all have low melting point. And a lot of heat is made during this reaction. Heat produced is more. Melting is easy. So it will melt. Hydrogen is produced, which causes the ball of the sodium to move around the surface of the water. Gas is producing, which is just helping the metal to move around. So white sodium hydroxide will be produced. This will be little white colored solution, which will dissolve in water, producing a highly alkaline solution. Alkaline means having pH more than 7. So overall, this reaction is faster than the lithium reaction. Okay. After that, we can move to the potassium. The potassium is going to be more reactive now. So let's see how the properties will change. Again, the equation is same. 2K in the solid form reacts with 2 water in the liquid form in a balanced equation, produce 2KOH, potassium hydroxide. Whenever we have OH, we studied in the ions as well, complex ions. OH negative is known as hydroxide, right? I hope you remember this. We are just adding the metal name at the start. Potassium hydroxide, sodium hydroxide, like this. We are giving the name to this alkaline solution, producing hydrogen gas as well. Potassium reacts more violently. Violently means more strongly or quickly as compared to sodium, which was at the top. Okay. It produces bubbles of the hydrogen gas as well. And now definitely there is going to be more heat. So it will melt just like a shiny ball, and that ball can just move around the surface. And when it is burning, it is also producing some flame. Okay, so that flame will have a color, lilac color flame is going to produce. That is an indication as well that it is potassium. Okay, so these are the three metals that we studied: lithium, sodium, and potassium. After that, if we just go back, we have three more. They're not telling us the equation for these three or any other explanation of these three, but in your exam in Cambridge and Edexcel, they will ask you to predict the properties. Means just make an idea. Let's say they are telling you, okay, you know about the group 1 metals. Tell us that how the cesium will react. Compare its reactivity with the sodium. Sodium and cesium. Which one is going to be more reactive? What will be the product? What will happen? Anyone can tell me. So when we are not sure about the things, but we can compare in the group. As we are going down, what should happen to the properties? That is known as predicting the properties. Anyone can tell me what should be the properties of cesium now? What should be the reaction of cesium now as compared to sodium? Yes. Okay, we have Samreen again. Yes. Okay, we have
Miss,
four. So I will ask all. Yes, Samreen. Please
Miss,
do not. Mm-hmm.
Miss, can I tell?
Yes, Samreen, sure.
Miss, I think like sodium, it will because more reactive as you move down the group. So
Hmm.
cesium react more than sodium.
Hmm. Right. And what will be the equation then?
So Miss, equation we can
Hmm.
write like 2CS plus
Hmm.
H2O and
Hmm.
2C uh 2CSOH, right? And
Right.
plus hydrogen.
Right. Okay, yes, Wafia.
Miss, I was going to say the same thing. Cesium is going to react more vigorously than sodium.
Hmm.
And the symbol equation is going to be CS, like the simplified version is CS plus H2O,
Okay.
gives you cesium hydroxide
Okay. You can also tell me about
and
melting. The cesium
hydrogen.
should melt or no?
Uh,
Is there enough heat for the cesium to melt on the surface or no?
I think, yeah, Miss, there's going to be enough heat for it to melt.
Right, because reaction is as we move down, more heat is produced, so they will definitely melt. So like this, we can
Yeah.
easily compare the properties of one metal to the other by just checking the position in the periodic table. Periodic table will always be given to you. You can just go back to the periodic table and see where they are placed, how they are linked with each other, and then you can just explain. Okay, so that is known as predicting the properties. So same they're doing over here, predicting the properties of the group 1 metals of rubidium, cesium, and francium. So rubidium, cesium, and francium all are definitely going to react more vigorously with water and air as well. Air means with oxygen. We'll also see these reactions. Lithium will be least reactive because it is at the top of the group. Francium is going to be the most reactive because it is at the bottom of the group. Okay. Okay, but for the Frenchium, it is very hard to check its reaction. Yes, Wafia, your question?
No, Miss, I wanted to tell why it's hard to check the reaction with
Yes,
for
yes, sure.
francium.
Sure, you can tell. Hmm.
So, Miss, actually, when you put francium like outside, it's going to react with air. So
Hmm.
it just causes it to like mix with the air, which makes it hard to check for its, properties and all that.
Right. Yeah. So francium is at the last, you can say in the group, so it is going to be most reactive. So as soon as we take out the francium out of oil, as it is stored in the oil, so that it can react with air or maybe with water, so we can check the properties. It will suddenly react with air, suddenly react with water that we are unable to check its properties. Okay. Plus, francium is very rare, means on the earth we have very small quantity of the francium. So we cannot take it again and again and test it. It is hard. Second thing is francium is also radioactive. Radioactive, have you ever heard about radioactive name before? What are radioactive elements? Any idea? Wafia, you have question? Or you want to tell
No, Miss, I wanted to answer.
something? Yes, sure.
Yeah. Miss, I think radioactive elements are, elements that produce like radiation, like give off
Hmm.
radiation.
Right. Yes. Radioactive elements are
Like,
basically any example. Yeah.
yeah, polonium, radium,
Mhm.
uranium.
Right. Yes. Well done. So radioactive elements are those basically which have unstable nucleus. Means they are unstable. They can quickly just change to something stable form. As soon as they change from unstable to stable form, they produce radiations. So those radiations can be dangerous as well. So they have very sudden and quick reaction. So francium is radioactive as well. Plus it is very highly reactive and it is rare. So all these things are making it hard to test and confirm their properties. So we can just predict them, not actually perform them in the lab or somewhere. Okay. So if we check out the rubidium, it is going to explode with spark, means reaction is so fast that it will look like an explosive reaction with water. Rubidium hydroxide is produced just like other. Cesium is going to be violent, very explosive reaction with a lot of heat produced and hydrogen gas bubbles. And again, it is going to produce cesium hydroxide. Okay. We can even, yes, Wafia.
Oh no, sorry, Miss, I forgot to lower my
Okay.
hand.
Umama,
Miss, where do we use these?
which one? The radioactive elements?
Yes.
Okay, we will have one lesson on it as well, but still I can give you a little idea here. Basically, radioactive elements we use in some nuclear reactions. Okay, so where we want to make, let's say, some nuclear material for atomic bombs, atomic energy. where we just start the reaction by putting some radioactive elements. They can quickly produce a lot of radiation and start a chain of reaction. Okay, so it has a lot of properties as well, a lot of uses as well that we will see in one separate topic. Yes, Wafia.
Miss, are all radioactive materials rare and like are they all hard to find?
No, not all are rare. Some radioactive elements are enough. Francium is the one which is rare, means less in quantity, but we have we have more than 30 elements in the periodic table which are radioactive, and some of them are available in a lot of quantity, in large quantity as well. Okay. Okay, so we can also check some melting boiling for points and densities of the group one as well. We can predict them, we can relate them with each other, and we can just get an idea. Okay, that's all about the group one. Now we can move towards the group 7 and let's see the properties of the group 7. Okay, before we look to the group 7, whatever we have discussed already about the group 7, and anyone can summarize and tell me the group 7, how many electrons should be there, how many they need, or maybe they should lose or gain electron to become stable, whatever properties you know about group 7. Jana.
Okay, Miss. Group 7 is always stable. They are called noble gases.
No, group 7, not 8.
Oh, this is group 8. Yes. Miss, I don't know.
Yeah, group 7. Yes, Jana.
Miss, I don't know what's the properties of group 7.
Okay, no problem. Yes, Mariam.
Miss, actually, group 7, they need one more electron to be stable. So
How
I
many
think
they have
that
already?
they have 7.
They
Then
have
out of
7.
this,
Group number is telling they have 7, right? So they need one more. Okay, what will happen? They will lose or gain,
they will gain one electron to be stable.
right? Okay.
And
Okay, yes, Wafia.
okay.
Anything else you want to add?
Miss, the halogens they're also called the halogens and they're diatomic. They're also like really poisonous.
Right,
And yeah, as they said, they have 7 electrons in their valence shell, so they need one more to stabilize themselves.
right. Very good. Yes, Judith.
Yes, Miss, I just wanted to, add something to Miriam's point is that because as we said earlier, they will gain one electron, so they will be negative. So this shows us that they are non-metals because metals are always positive.
That's very good. All the points are correct. Okay. So group 7 are also known as halogens. When we studied about groups, we said that group number is telling us how many electrons are in outer shell. So group 7 means they all already have 7 electrons in the outer shell and they just need one more so that total will be 8, and 8 electron in the outer shell means they are stable. So for having one more, they are going to take electron now. 7 is already there, taking one more. So whenever something takes electron, it is known as non-metal. And when they lose electron, then it is metal. So it means all the group 7, the halogens are non-metals as they are taking one electron. Okay, so the non-metals, most of the time they are not present in the form of single atom, they are present in the form of diatomic, means two atoms together. So all the group 7 halogens will be present F2, Cl2, Br2, I2, like this in the diatomic form, two atoms together. They are also poisonous, and examples include fluorine, chlorine, bromine, iodine, istidine, all are basically poisonous. 7 electrons in the outer shell. Outer shell is also known as valence shell. This thing we already studied. Okay, so when they are going to gain one electron, it means they are going to get some charge as well, negative charge, right? So when halogens get one electron, become negative ion, we say negative ion anion, right? But we also say them halide ion from halogen name. Anion is a general term for all the negative ions we said already, but halide ion means the halogens, when they take one electron, become negative ion, they are known as halide ion. Okay. So now we will see about their physical properties and then we'll talk about their chemical properties and how they are reacting. What will happen if we go down the group? What will happen to the reactivity? And I will ask you guys, checking their size, And keeping this thing in mind that they needs the electron now, not removing electron, just like the group one. What should happen to the reactivity? I will ask you the question. Okay. So first of all, let's see some physical properties. Physical properties, we are going to see their physical state first of all. So we are going to see the physical state at room temperature, approximately 20 degrees Celsius we are taking as room temperature. Room temperature can be different, 20 to 25 somehow. Okay, so top of the group, they will be gases, then liquid, then solid. So their physical state becomes, you can say, denser, or you can say physical state is going towards the solid as we go down the group. So top one, chlorine is going to be, fluorine is also a gas, having no color. Chlorine is also going to be a gas with a little pale yellow to green color. Then after that, we have bromine. Bromine is going to be liquid, red brown. It can evaporate and go to the gas state as well, but at room temperature, it is going to be liquid. And you remember, we said that bromine is the only non-metal liquid at room temperature, and mercury was the only metal liquid at room temperature. This is also one important exam question. Then after that, we have iodine and acetylene as well. After that, all these two are going to be solid and darker color, gray color, black color, you can say about this, and they are going to be solid. If we talk about their density, density increases. As they're going from gas, then liquid, then solid, as we are going to down the group means they're becoming more denser down the group. So density of the halogens increases as we go down the group. So that's about their physical properties. Let's see chemical properties, reactivity. Okay, now it's your turn to tell me the explanation. Here is the example of chlorine, bromine, iodine. Let's compare the reactivity of chlorine with iodine. What should happen to the reactivity down the group? Okay. Yes, who can tell me? Let me see the hands. Do we have any new student here? Mariam, Jude, and Wafia. Okay, let's ask all three one by one. Yes, Mariam, first of all.
I think as we go down the group, the activity will be less.
Reactivity will be less. Okay, why? What should be the reason?
Actually, because the upper the group, it will be
Hmm.
the less the shells. So as the electrons are gained, so the
Hmm.
nucleus will يعني it will be easier to it will be easier to get the electrons.
Okay. Okay, I will tell at the end that it is right or no. So first, let's ask other students as well. Yes, Jude.
So Miss, it will, as Miriam said, it will be the reverse. So their activity is stronger at the first element, and then as it goes down, the activity becomes lower. So
Hmm.
the reason is the reverse. So in the for the metals, as we said, because they are losing the electron. So
Hmm.
because when it's away from the nucleus, so it's easier because there won't be so much the from the
Hmm.
protons and electrons, the charges won't be together. So here they want to gain the electron. So if it's up, so the shells are less, so they'll be gaining, for example, in the second shell, so it's nearer to the or it's closer to the nucleus, so the electron and the protons will attract each other.
That's right.